Alright, so right now I have open the practice file 4 that you can download on Brightspace. This practice file is really close to what you're going to see on your final hands-on on Monday. So let's run through this and kind of go through all the configuration steps that you'll need to do for the actual final here. I think it's best to start off with little chunks of the network and kind of build your way out from there. It could be a little overwhelming if you just look at the whole thing here. So let's just start with the public side. We have a VLAN 10 for the PCs we need to configure, as well as a VLAN 20 for the laptops we need to configure. And we need to have a router on a stick configuration with the public router. So let's get into the switch here. So enable and config T. First thing I recommend doing is you go into the line console and you configure your logging synchronous, and you enable your executive timeout zeros. Logging synchronous, executive timeout 00. That'll stop status messages from interrupting your command line, and it'll stop you from having to log back in when you're away from the router for too long. Back to global config. First thing I'd say we should do is let's go ahead and name the switch, because right now it's just switch. So that's host name, public switch. Let's get in here and let's name our VLANs. So to create a VLAN, if you remember, you just type in VLAN 10. That'll create the VLAN and move you into the configuration mode for that VLAN. Give it a name. Let's give it name PCs. And to create VLAN 20, we just need to do VLAN 20 name laptops. So let's mouse over this here and let's see what we have for our connection. So gigabit 01 is going to be our trunk port. Interface gigabit 0/1. A command for that, switch port mode trunk. That's enough for that one. Now let's get into all the rest of the Ethernet interfaces. So that's interface range fast Ethernet 0/1 through 24. So we want to take them from dynamic, and we're going to do switch port mode access. Switch port security. Remember, port security by itself is how you enable port security on these ports. Switch port security MAC address sticky. That's going to tell it to dynamically learn and remember the MAC addresses that are connected to these ports. And switch port security violation mode. We want to go ahead and give it this shutdown. We want these to turn off when a violation occurs. Alright, so right now we're selecting all 24 ports. We're going to want to probably cut this in half. So we're going to do exit, interface range. Let's grab the first 3. For the PCs there, actually just grab the first 12. Switch port, we already did switch port mode access, but we need to do switch port access VLAN 10. Let's switch over, we'll grab the range of 12 through 24. And then the switch port access VLAN 20. There we go. Exit. Let's come up over here and let's make sure they're plugged into the proper address, proper ports here. So we've got 1, 2, and 3. These guys are probably going to be 4. Yep, so let's drag these. We're going to put these in 12, 13, and 14. There we go. Now they're in the proper ports for their VLANs. Now we need to configure our router on a stick. Let's hop into the router. Let's turn it on if it needs to be turned on. Watch it come up here. So enable config T, hostname, public router. Go into the line console, do logging synchronous. We want executive timeout 0. Let's take a look here. Should be gigabit 01 on that end too. So even though we are not using the native VLAN, we are not going to give this an IP address, we still need to bring it up with a no shutdown command. Alright, next let's create our sub interfaces. Interface gigabit 0/1 dot, and you can number them whatever you want, but we should keep them, keep it all the same. So VLAN 10, we should give it a .10 just to make it easier on ourselves later on. And that command right there creates it and brings it up, so you don't have to issue a no shutdown command there. But we do have to give it an encapsulation .1Q and specify the VLAN this is encapsulated for, 10. Let's give it an IP address. So this is going to be for the 192.168.10 network. And best practices, we should always give our router's interface that first available IP there on the network. So 192.168.10.1, 255, 255.0, because this is a /24 network. There we go. Let's up arrow. And we'll create our .20 sub interface. We'll do our encapsulation .1Q20. And let's give it the IP address of 20.1. There we go. So we got that interface up and running. We've got our router on a stick configured. But we still need to do our DHCP services right here. Let's exit out of this. Do IP, DHCP, pool. We need to specify a name. And again, let's keep everything standard so it's easy to identify across the board. VLAN 10 is going to be the name of this pool. We're going to specify what network that this pool is for, as well as the subnet mask. We need to specify the default router, or the default gateway that these PCs will have as the clients, which is going to be the IP address of the router, as well as the default, as well as the DNS server for the pool. So that's it for the VLAN 10 pool. Let's create one for 20. Again, just stay with the name. You know, that is the same across all of our networks. So VLAN 20 network 192.168.20.0 with the subnet mask. Make our default router 192.168.20.1 because it should be the first IP in the subnet, as well as our DNS server 1.1.1.1. You can pick any well-known DNS server. You can pick Google's 8.8.8.8. I'm just picking 1.1.1.1. Alright. Let's hop on here. Let's see if we can get a DHCP address. There we go. So it's not specified here on the settings. You will need to exclude the first 10 IP addresses on your final. So let's do that in here as well. Let's get out of the DHCP config. Let's go into IP, DHCP, and then do a question mark there. excluded addresses. So notice this is in the global config. This is not in a pool's DHCP config, just the global config you run this command. So it wants to know the low starting address. We're going to block off 192.168.10.1. It wants to know the high range, so we're going to do 10.1 through 192.168.10.10. We'll block off the first 10. Let's up arrow that. We're going to block off 20.1 through 20.10. There we go. So let's check some the clients here and see if we can get our DHCP addresses. There we go. There we go. All right, so that's working like it should. Let's get the rest of these DHCP clients up and running. Now we haven't done it yet. It's really important that before you submit your final or any of these labs, do not forget you can either run the copy running config starting config, or you can use the WR, the write command, to build your configuration. But definitely save the configuration on these devices before you submit anything for finals. But this router's not quite done yet because we have a /30 network, a little point-to-point connection here between the two routers that we need to bring up. This is serial 000. Interface serial 000. IP address. So we're going with 10.0.0.0 for the network and a /30. So that means we have two usable IP addresses. The first one is 10.0.0.1. Our subnet mask will be 255.255.255, but this is a /30, so it's going to be 252. We'll give it a no shut. So you notice even though we gave that a no shut, that it's still not up yet. That's because with serial interfaces, they will not come up until both sides of the interface are up. There's a do write. Last thing we need to do on this router, we're going to do router rip version 2. And let's specify the networks that we want to have advertised over RIP. So we need to name off the directly connected networks on this router. Network 192.168.10.0, network 192.168.20.0, as well as network 10.0.0.0. There we go. You're done with that router. So let's move on down to this router here. That switch. So before we begin even, let's check and see what connections we are using for the trunks between switches. We're using our gigabit 1 and 1 between there, our gigabit 2 and 2 between here, and our gigabit 0, 1, looks like. 0, 1 and 0, 0. I'm going to switch this to 1, just because that's a lot easier to remember. So these are all of our gigabit ports. So our fast Ethernets are for the PCs, and our gigabits are our trunks. So let's enable config T. First thing, let's switch our host name out here. Let's say switch 50, since this is all for the VLAN 50. Let's get into our line console 0. Let's do our logging synchronous, as well as our executive timeout 00. And let's get in and configure our VLANs. So we need VLAN 40, name PC40, VLAN 50, name PC50, and VLAN 60, name PC60. Alright, let's get into our gigabit ports. 0/1. So we're going to do interface range 0, 1 through 2. Do switch port mode trunk. These are going to be our trunk ports. And let's do a do right. Let's exit out of here. And let's get our trunk ports configured on this router. Let's do hostname switch 60. Login console 0. Login synchronous. Executive timeout is 0, 0. Interface range gigabit 0/1 through 2. Switch port mode trunk. And let's go ahead and get out of here. So we're going to have this switch here be the VTP server. Top back into that one. Let's set the name while we're there too. So we go VTP. Search this out. Looks a little bit more readable. So let's set the domain of Cisco. Change from null to Cisco. Let's do a do show VTP status. So this one is already set in server mode, so that's fine. Let's hop to this one here. Do show VTP status. So the domain name has already spread across. We have our VLANs that are up and running, but it's set as a server. So let's go VTP mode client. There we go. And show VLAN brief. So cool, our PC 40, 50, and 60 VLANs have propagated here. Let's check our last switch. Hostname switch 40. Line console 0. Login synchronous. Executive timeout 0. Now, you probably noticed by now we're not setting our passwords right now. I'd recommend waiting till the end, just so if you have to, you're saving and exiting and reloading your router a whole bunch, you're not constantly have to add in your passwords. Let's do a VTP mode client and do a do show VLAN brief. Let's see, 40, 50, and 60. All right, are there. And it's safe to say if we do a do show VTP status, we should see the domain name of Cisco, and that got across just fine, so that's great. Do right. So with each of these switches, you know, the entire block of ports are all for one VLAN. We've got VLAN 40, VLAN 50, and VLAN 60. So we don't have to go through like we did up here and assign half and half. We can just assign all fast Ethernet ports to be VLAN 40. Let's go interface range fast Ethernet 1 through 24. Switch port mode access. Switch port access VLAN 40. Switch port security. Let's turn on port security. Set the violation mode to shutdown. Set the MAC address mode to sticky. Let's do a do right. We'll head on to the next switch. Interface, range, fast Ethernet, first one through the last one. Switch port mode access. Switch port access VLAN. This one is for VLAN 50. Switch port security to enable port security. Switch port security MAC address sticky. Switch port security violation mode shutdown. Do a do right. Save that configuration. Let's move on to the last one here. Interface range fast Ethernet 0/1 through 24. switch port mode access, switch port access VLAN 60. Excuse me. I'm going to turn on port security. Set the MAC address mode to sticky. And set the violation mode to shutdown. Alright. So we have our switches configured here. Let's configure our router on a stick. Let's do our host name, staff router. Let's get to the line console 0. Set our logging synchronous, as well as our executive timeout. Let's get into our interface gigabit 0/1. So we're not using our native VLAN. We don't need to assign this an IP, but we do need to bring the interface up with the no shutdown command. So now we can go in and create a sub-interface. We're going to be creating sub-interfaces 40, 50, and 60. So let's go to 40. And first things we need to do is do encapsulation .1q 40. This is going to be our sub-interface 40 for VLAN 40. Give it an IP address. And best practice there is to give it the first IP address in the network, 192.168.40.1. This is a /24 network. There we go. We can hit up and go back and create our last two sub interfaces here. So 40 to 50 should be 50.1. You know what? Let's do our encapsulation of 50. There we go. And now we can do our 50.1. Let's create our .60 sub interface. Our .60 encapsulation there, and we'll give it 192.168.60.1 for its IP address. Alright, so we should see our sub interfaces there, 40, 50, and 60 with the proper IP addresses. Alright, let's configure our DHCP addresses here. IP DHCP pool VLAN 40 for the name. This is going to be for the network 192.168.40.0. We're going to have a default router is going to be the router's IP address for this network, which is .1. And the DNS server 1.1.1.1. So we can repeat these steps, but just change the network number for these last two DHCP pools here. So let's call this one VLAN 50 pool. Same DNS server. The default router is going to be 50.1. And the network is going to be the .50 network. Up arrow to get IP DHCP pool again. VLAN 60 for this one's name. It's going to be the .60 network. And the default router will be 60.1. And we can use the same DNS server. Let's see if we can get an IP address here. We go 40.2. So let's say if we want to block off the first 10 IPs to keep those from being handed out via DHCP, your IP DHCP excluded addresses 192.168.40.1 through 192.168.40.10. Now let's just up arrow 50.1 through 50.10. Up arrow again, we're going to do 60.1 through 60.10. So now we have those first 10 IP addresses are excluded. Let's bring this last interface up here. So we have 001, interface serial 0/0/1, IP address. So we have the .4 network, which means we have two usable IPs. First one's going to be 10.0.0.5 with a subnet mask of 255.255.255.252. We'll give it a no shutdown. Bring that interface up, but it will not turn on until we have both sides of these interfaces up. So we'll router RIP version 2, and let's identify the networks we want to advertise with RIP. So we're going to broadcast this network, this one, this one, and this one, all the directly connected networks. So network 192.168.40.0, 50.0, and 60.0, as well as the network 10.0.0.4. Okay, let's hop onto the backbone router here. Host name, backbone. Enter the line console 0. Let's get logging synchronous, executive timeout 00. And let's get onto our network interfaces. So if you look here, there are no VLANs present here. There's no DHCP, everything's static. So I think we have to do, we have to go in here and manually specify the IP addresses for these servers here, as well as give the IP address here, but there's no router on a stick configuration here. So that should make it a lot easier. Let's get an interface, gigabit 0/1. So our network is 10.0.10.0. So the first available IP address is what we want to give the router. IP address of 10.0.10.1, 255.255.0. Give it a no shutdown, bring up the interface, and let's move on to these last three interfaces here. Interface serial 0/0/0. It's for this one right here. IP address, so this is a /30, so the .0 here is the network. 1 and 2 are the available IPs. We used 1 here, so this one is going to be 2. And the subnet mask for this, since it's S/30, is 255.255.255.252. Let's give it a no shut. You can see this interface come up now that both sides are up. Let's get to the second serial interface here, 0/0/0/1. Same thing here, the network is .4, since this is a /30. We used 5 down here, so the only other available IP is .6. With a subnet mask of 255.255.255.252. Give it a no shutdown. There we go, and the interfaces come up as well. Excuse me. Right, let's see what this last interface here is. It's 0/1/0. Interface serial 0/1/0. So give it an IP address of 10.0.0. So the network is 8. There's only 2 available IPs, not 9 and 10. So let's give it 9. Subnet mask of 255.255.252. Let's give it a no shutdown. This won't pop up until the other one is up. Let's write that configuration. And before we do anything else, I just want to bring this up. Let's hop onto the internet here. turn it on if it needs to be turned on. Wait for the configuration to load. And no, we want to skip this initial configuration. So enable, big T, do hostname, internet, line console 0, logging synchronous, executive timeout 00. Let's hop onto this serial interface. Which one is it on this end? 000. So IP address, we already used the .9, so .10 is the only other available one. Let's get our RIP up here. We got one network to advertise, and that's fine. All right. So let's advertise our routes here. Router RIP version 2. Excuse me. So 10.0.0.0 is one network. .4 is the next one, and .8 is the one after that. We also want to advertise this network right here. So network 10.0.10.0. Let's do a do show IP route. I don't need to do that, do I? Nope. So you only need the do if you're in a different global config. So just show IP route will work. So here we can see we have our 10, 20, 40, 50, and 60 networks, as well as our 3 directly attached networks in the 10.0.0.0 areas, and their 10.0.10.0/24 network are all there. So let's look at our servers here that we need to statically assign IP addresses. So this one needs to be 10.0.10.11. Now, because it's a 10 dot, it wants to give you the default subnet mask of a /8. We want to make that a /24. With the default gateway of 10.0.10.1. In our proxy server, 10.0.10.12, 255.255.255.0, 10.0.10.1. Get these last two up here. Alright, so now we have our statically assigned IPs there. The last thing we need to do is configure a few access control lists. So it looks like we need to make sure that the public LAN, so this area up here, this public LAN, cannot reach the staff server. So that server right there. The internet, right there, or the staff network. Anything right here. So you could accomplish this with a bunch of standard access control lists at the closest interface to the destination. So you could put one here, blocking the public, put one here blocking the public, and put one here blocking the public. But I think the easiest thing to do would be use an extended access list and put one right here, blocking the public. Now, You can do it either way you want. You're not going to lose any points for going through and doing a bunch of standard access control lists. Doesn't matter how you do it, as long as it blocks the traffic that it's supposed to and allows the traffic that it's supposed to. So let's hop in this router here, the public one. We're going to do an extended. Go back to global config, access list. Let's do an extended. And we're going to start denying traffic. So we're going to deny 192.168.10.0 as the source address. But first, actually, we got to go back here, and we're going to block ICMP traffic. It's because we're going to test this by pinging, so we want to make sure we are blocking that type of traffic so we know that our ACLs actually work. So that's our source address, and we want to block any of that going to our staff server, which is 10.0.10.14. So when you do your wildcard bit here, in the past we've always done .255 selecting anything in this last octet. Well, we just only want to specifically block the staff server. So we want to match in every octet there. The next thing, let's up, because we still want to block, everything's going to be the same. We want the same access list number. We're denying ICMP from this source network. The only thing we're going to change is our destination network. And here we are blocking them from reaching the internet. Which is, let's see here, 10.0.0.10. 10.0.0.10, and again, all zeros because we want just this one host to be blocked. Let's do one last one here. So this destination address, we are going to block the VLAN 40, 192.168.40.0, 0.0.0.255. Up arrow, we're also going to block it on the 50. And we're also going to block it from reaching the 60. So what we've done here is we have created an access list to show run as effectively taking the source address of this 192.168.10 network and blocking it from reaching our staff server. We say deny it from reaching the internet, deny it from reaching VLAN 40, VLAN 50, and VLAN 60. So it'll block all it's supposed to block, but don't forget there's that implicit deny. So if the traffic coming through does not match any of our rules, the router is going to drop the traffic with that implicit deny. So we need to go in and remember to give it a permit. So permit ICMP any. Let's do our do show run again. So since access lists, when they are compared to the traffic, are done sequentially, it will go down through and check traffic and say, okay, you are the one, are you this network trying to reach this host? And it's going to go, if it is destined for the staff, it's going to get dropped. If it's destined for the internet, it's going to get dropped. If it's destined for any of the staff VLANs, it's going to get dropped. But if it doesn't match any of those, it's going to get down to this last statement here and say permit anything. And that's going to let the traffic go through. So our access list is ready to be applied. Because creating the access list isn't enough, you have to actually apply it. So we're going to go into interface, gigabit 0/1.10 for our VLAN 10 here. We're going to do IP access group 110. And it wants to know if this is inbound or outbound traffic. Well, as the traffic is coming up the segment here on the router on a stick, it hasn't got to the network, the router yet. is trying to get into the router. This is going to be in. And now we need to create another access list for our VLAN 20. Access list 120 deny ICMP the VLAN 20. We're going to block it from reaching, I'm going to do these all pretty quickly. We're going to block it from reaching the internet, from the staff, and from any of the staff VLANs. And that one's the internet. VLAN 40, VLAN 50, VLAN 60. So blocked. We blocked it from reaching the staff server, the internet, or 3 staff VLANs. Now we need to give it access list 120 permit ICMP any. That way the traffic can flow for anything that doesn't match these. Otherwise, if you don't put in that any, or at least some permit for the traffic you want to go through, it will get dropped. Let's go on our interface, gigabit 0/1.20, IP access group 120. This is traffic trying to come into the router interface, so we're selecting in. Save that configuration and exit. Last little bit we need to do here. Make sure that the staff cannot reach the public server. Let's see. Excuse me. So let's get our access control list here. It says staff can't reach the public server. Access list, let's see, 140. Deny ICMP traffic from the 192.168.40 network. Trying to get to the public server, which is the 10.0.10.11 address, with 4 zeros for the wildcard because we want an exact match. What did I miss here? Oh, there we go. I missed that first wildcard there. 0.0.0.255. There we go. And that's all we're blocking for this one. We're going to do a access list 140 permit ICMP any. Now we can just up if we want to. You can really type it all out, but there's no difference. Access list 150. We're going to deny 150 from accessing the staff router, the public server, and we're going to allow any other traffic. I'm going to go back up, and we're going to do one for 160. Deny the .60 network from reaching the public server. And then we're going to give the rest of the traffic a permit any. Last thing we need to do here is go into the sub interfaces and apply these access control lists. IP access group 140 in. It's up arrow. 150. Sorry, not 150. .50. And we're going to apply the 150 in. So this makes it pretty clear how useful it is to keep your 50s and your 50s and your 50s all together across the board. It makes it really easy to kind of stay mentally organized here. 0.60 and 160 in. Let's do right. And there we go. Now we properly have this whole lab configured. This is really close to your final exam. If you can do this, you can do the final exam no problem. You should be good to go.